In this demo, we'll get started with using configuration in ASP.NET Core. We'll learn about the appsettings.json file, which can be used to define your application configuration using JSON. We'll look at some of the default configuration included in applications created using one of the ASP.NET Core project templates. We'll conclude by defining some custom configuration entries which we'll use to control the content shown on the web application's homepage. Here is the homepage for the Tennis Club website, which is in an early phase of its development. Currently, it displays some information about the club. We'll improve the homepage by adding a random greeting for visitors and details about the current weather conditions near the tennis club. We'll begin by defining configuration values that will control the homepage's features. These will act as basic feature flags, allowing us to enable new features once they're ready without requiring a recompilation of the application. Should these new features introduce any bugs or problems, we can use configuration to disable them very rapidly. This web application was initially created using one of the default ASP.NET Core templates. The ASP.NET Core templates include a file called appsettings.json at the root of the solution. The appsettings.json file can be used as a source of configuration values for a .NET or ASP.NET Core application. Inside this file, we can define configuration using JSON. When using the default web application host, this file is read by the JSON configuration provider to load the configuration automatically at startup. I'll open the file by double-clicking on it. The content of the default appsettings.json file is relatively sparse but does include some default configuration. In a new project, configuration to control logging and the allowed hosts will be present by default. These configuration entries control ASP.NET Core behavior. Other configuration entries, including those that we'll introduce during this course, are designed to control the behavior of our application-specific code. Storing the configuration for logging in a configuration file ensures that if we wish to change the default logging level, which will be included in the logging output, then we can do that without requiring a rebuild of the source code for the web application. This can be useful to enable more verbose logging in production whilst diagnosing a problem or a bug. In this case, there's a subsection named log level, which is under the top level logging section. Within that section, two configuration entries are defined. The first entry has a key named default and is used to define the overall default log level for the application. This has a string value set to information. A second entry named Microsoft.ASP.NET Core is also included with its value set to warning. This is used to define a more specific log level for that namespace. You can see the hierarchy of configuration values at work here, with the related configuration grouped into sections within the JSON object structure. There's also an allowed host entry that controls which host headers this site responds to. This is not included inside an object used to define a section and is simply a configuration key and value. Besides the default configuration entries, the sample application includes some extra configuration required for it to function. I've hidden most of these as they're not important for us to focus on right now. We'll be defining additional configuration as we develop new features for the tennis booking application. At the top of the file, there's a section called Connection Strings. Connection strings are used to configure an application to connect to a remote database. This application has a single connection string entry called SQLite connection. The sample application uses SQLite, a small, fast, self-contained SQL database engine. This is done to make running the sample application simpler with fewer dependencies. Real-world applications will likely use a relational database server such as SQL Server or Postgres. The value for SQLite connection is a string representing a connection string used to configure SQLite to use an in-memory store. We'll see where this configuration value is used in an upcoming clip. I'll paste in some new configuration to this appsettings.json file. This creates a new section named Features. Within this section, I've defined a subsection called Homepage, which is used to logically group any configuration that controls the content on the homepage. I've created two Boolean configuration entries, each of which will be used to control a specific feature on the homepage. The first configuration entry is called Enable Greeting, and its value is set to true. This will control whether a random greeting feature is shown on the homepage. A second key called Enable Weather Forecast has its value set to false, and we'll use this to control if the weather forecast will be shown. Finally, I've included a key called Forecast Section Title. Its string value will control the title rendered on the homepage above the weather forecast. We have now defined some additional configuration entries, and by updating and saving this file, they'll be available when the application starts. We'll make use of these configuration values in the following clip. In this demo, I'll introduce a technique for accessing application configuration at runtime. We'll begin by injecting and consuming the configuration which controls the homepage features within the page model for the index page. The Razor file for the index page will conditionally render its content based on the values in the model that have been provided by configuration. Let's begin by opening the page model for the index page. The index model class includes the properties and methods responsible for returning the homepage content. Some of the work to define the properties which control the greeting content on the homepage is already complete. I've included a string property which will store the randomized greeting text which should be displayed. I've also included a Boolean showGreeting property which will be true as long as the greeting property has some content. We're now ready to consume the configuration that we defined in the appsettings.json file. ASP.NET Core is built upon the foundation of dependency injection. To gain access to application configuration, we can inject an iConfiguration instance via the index models constructor. To do that, we'll add a parameter to the constructor of type iConfiguration. We'll name this parameter configuration and store it into a private field within the class so we can access it from the onGet method when that gets invoked. The iConfiguration interface defines the methods and properties that can be called to access configuration values by their key and section. Let's retrieve the configured value that controls whether we should show the randomized greeting message on the homepage. Because we stored a reference to the iConfiguration instance into a field, we can use it to access the configuration value that we need. In the onGet method, we'll access the value using its full key name. For this demo, we'll request the value directly. We can do that by calling the getValue method on iConfiguration. Since the value we expect here should be a Boolean, we can pass the expected type as a generic argument to this method. The method requires an argument to identify the full name of the key that we want to access. Remember that we defined a features section and then a homepage subsection below that in the JSON file. That established a hierarchy for the configuration keys which we included in the homepage subsection. That hierarchy will be flattened when the configuration is loaded from the JSON object. We can access the key directly by including its full hierarchy, which in the flattened form uses colons to separate the sections. In this case, we'll use features, homepage, enable greeting, which includes the complete hierarchy of the key we're interested in. Because the configuration value is a Boolean, we can use this directly as the condition for our if statement. If the configuration value is true, then the injected iGreeting service will be used to set a random greeting for the index page by assigning a value for the greeting property on the model. The greeting property won't be set and will remain empty when the enable greeting configuration value is false. What will happen if the configuration value is not found at all, I hear you ask? Great question. If the key cannot be found, then the value will be whatever the default value is for the type specified as the generic type argument, false in the case of Booleans. If we view the Razor page for the index, it already includes code to consume the properties defined on the page model in order to render the greeting content onto the page. If the showGreeting property returns true, the code here renders the greeting onto the home page inside a h3 tag. This should be everything needed to complete the new greeting feature. I'll build and run the application by pressing F5 to see the effect of these changes. The random greeting is now shown on the home page because we set the configuration value to true in the appsettings.json file. If I refresh the page, a different greeting is shown. Injecting iConfiguration provides a way to access the application configuration from places which support dependency injection. In ASP.NET Core, that's pretty much everywhere, such as from views, Razor pages, middleware, controllers, and within your own services. If I stop the application, return to the appsettings.json file, and configure enable greeting as false, when I rerun the application, the greeting is no longer shown. Were this a feature which had introduced a bug, we could quickly use the configuration to disable it until a fix had been created. Before moving on, I'll re-enable the greeting in the configuration.